Hi, so today we'll talk about section 11.1. This is quite a very simple section. It's called sequence. So sequence is a fairly simple term. It's just like if you have a sequence that share the same formula, like you have one most famous sequence is the Fibonacci number, which is f1 f of n equals to f of n plus 1. Oh, sorry. F of n equal to f of n minus 1 plus f of n minus 2. And that is a sequence, which means you have the first number is 1, 1, 2, 3, 5, 8, 13, and so on. It's because the current value is the sum of the two previous values. So that's the Fibonacci sequence, and that is an example of a sequence. So because the theory of sequence is fairly simple, we will now move to a much more complex problem, which is finding to check if the sequence is converge or diverge. So let's say if you have a sequence of an in which an is equal to ln of 3n plus natural log of 6n. So you want to check if when n is going to infinity, will the sequence converge, which means it will end up in a very specific value, or it will diverge, which means it will run forever and go to infinity. You cannot find like the ending point of the sequence. To solve this one is very simple. So you know the very basic calculation of natural log. So you have like natural log of 3n and natural log of 6n is just natural log of 2 plus natural log of 3n, right? Because when n is go to infinity, you cannot find the limit of this one. You cannot find the limit of an if you just like keeping the equation like this one. So you have to break it down like this. And what I'm going to do is it will be equal to 1 over ln natural log of 2 over natural log of 3 and plus 1. This is very interesting because natural log of 2 is a constant. Natural log of 2 is constant. And natural log of 3n, as n go to infinity, will go to infinity, which make the whole things go to 0. So as n go to infinity, these equations go to 1 over 0 plus 1, which is 1. So, which means it is converged. Let's take a look at another example. And I found fairly interesting. One more example is the using of trigonometric function. So they want to ask you to see if the sequence, let's say cosine of like 5 over n is converged or diverged. So you know that the limit when n goes to 0 of an equal to the cosine Sn of 5 over n as n go to infinity. So as 5n go to infinity, like Sn n go to infinity, 5 over n will go to 0. Right? As n go to as phi of n go to 0, you know that cosine of n, the cosine of 0 is 1, right? So it will make this equation converge. Okay? Let's take a look at another example. Because this section is fairly simple, so all you need to do is just finding the way to find the limits and to but very be careful, because if the question asks if like cosine of n over something, like n over 8, as n go to infinity, the value of cosine is unidentified. That means you cannot find a specific value for n, which leads to the fact that cosine will running back and forth between -1 and 1. So in that case, you won't be able to find or to determine if this sequence is converge or diverge. And let's finish with a very basic one. As I said, this section is very simple, and it is very easy for you to get used to it. So a of n is what's in 9 plus 3n squared over n plus 8n squared. Okay, this is very interesting because as n goes to infinity, both the denominator and numerator go to infinity if you keep it like this one. So what I'm gonna do is a very basic way of finding the limits, like as you always do, as n go to infinity. What you normally and most of you will do is 9 over n squared plus 3 divide both numerator and denominator by n squared. This one will be like 1 over n plus 8. Now that look more promising because as n go to infinity, this one will go to 0. And this one will also go to 0 because it is a constant over n. If it is like n over n squared or something, you cannot do it. Oh, actually, n over n squared is go to 0 also. But if it's like a two polynomial, like on the numerator and denominator, you cannot do that. Which then it go to 3 over 8, which is converged also. The problem of sequence with the first section of this chapter is very simple. I think it will be on the exam, but the part that you should really focus on the exam will be the chapter 10. And this Thursday will be the exam review, and I will show. And please bring your homework and bring your problems to me, and then I can solve it to you. All right. Thank you.